All right, today and tomorrow we are going to be talking about surface area. So we've covered volume of cylinders, cones, and spheres, and now we're going to talk about surface area of rectangular prisms and cylinders. So surface area is the amount of space covering the outside of a three-dimensional shape. So kind of think about like wrapping paper. How much paper would you need to cover something? All right, area is measured in square units. So remember, volume is like you're filling it up with cubes, so it would be cubic units, like inches cubed. Area, or surface area, both are square units. So how many little squares would it take to cover something? And then regular measurements like radius or height don't have an exponent. They would just be inches or centimeters, whatever the unit may be. But area, it's like we're taking all these tiny squares to cover something. Or if you've ever heard of like purchasing flooring by the square foot, it's how many squares that are 1 foot by 1 foot you would need to cover your flooring. So surface area is square units. Volume, we're taking those three-dimensional cubes to fill up. So we do expect you to know the difference for those. So let's talk about rectangular prisms today. We'll talk about cylinders tomorrow. So for a rectangular prism, there is a formula down here. Surface area equals 2 times length times width plus 2 times length times height plus 2 times width times height. But sometimes it's also just easier to think about what's going on in our picture. So if this is my length, width, and height, this first square is going to be length times height. Because right here, if that's my height's here too. So I'd have length times height, and then I would have 2 of those, right? Because I have this one in the front and this one in the back. Okay, so that's 2 of my 6 sides. And then if I wanted to do this skinnier piece here, I'd have width times height. And again, I'd have 2 of those because I have one on the right here and one on the left. And then the last section, I'd have 2 of these length by widths, or here there's one on the bottom, length by widths. And I'd have 2 of those because I have one on the top and another one on the bottom, right? So that's really where this comes from. You are welcome to use the formula, but it's not something that you really need to memorize. You can just look at the pattern, right? So let's do an example. So for this one, we have 12 by 15 by 6. And I want the surface area of this rectangular prism. How much wrapping paper would I need to cover this box? So for our surface area, let's talk about this front piece first. This front piece, which is the same as the back piece, would be 12 by 6. So we have 2 12 by 6s. Okay, and actually let me highlight so that it's just really clear what parts we're talking about. So that was the front here and the back here. Okay, and then let's talk about the sides. So then I have on my sides are 15 by 6. So I have 2 15 by 6s. So let's highlight those in green. That's these 2 sides. And then we have one more, the top and the bottom. So my bottom piece looks like it's a 12 by 15. So 2 12 by 15s. Okay, so that's my top piece and my bottom piece here. And it gets a little bit confusing at that point, but that's where all of our dimensions come from. 1 from each type of side, and then there's 2 of each of those. So if I just type that into my calculator, you can do the whole string. If I do 2 times 12 times 6 plus 2 times 15 times 6 plus 2 times 12 times 15, I get 684 square inches. Oops, that's not what I want. Okay, because it's like I'm taking a 1 inch by 1 inch square. I would need 684 of those to completely cover our rectangular prism. Okay, So that's how you do these. All of them are going to be the same today. And next you're working on a Delta Math assignment.